Hey friends, I'm Scott Hanselman. This is Azure Friday. I'm here with Raghav Mohan and we're talking about Apache Kafka. Last time we met, we did an introduction to Kafka. Yep. So what's changed since?
So we've had a lot of exciting new features that we've built out in Apache Kafka. And not only have we built out these features, but we've also lighted up a lot of scenarios for enterprise use cases. And while the service is in preview, customers have taken a dependency on this in production. So these include scenarios like Bing Ads, and they had some requirements around security and compliance, and they wanted to marry the power of compliance with the open source technologies. Mm-hmm. So they're using Kafka to generate a lot of ads dynamically, and they've been able to reduce on a lot of costs and still get that scale with Kafka today. In addition to this, we have scenarios that encompass, like, we've been working with large banks to build out their fraud detection scenarios, and Kafka is a real-time ingestion technology, so it can really handle millions of events per second. So each time you swipe that credit card, that gets processed on Kafka, and then you get the notification there. Wow. Another scenario that we've been actually working very closely with is the connected car scenarios that Azure powers. So we've been working with one of the largest car providers like Toyota, and they built out their connected car on Azure. And Apache Kafka is the primary technology that drives this car forward. Yeah.
So from a perspective of a person sitting in the car, when I think connected car, I plug my phone into the car and I drive. What is a scenario that is for a connected car? What does it power?
Yeah, so that's a great question. As a person sitting in the car, if you're even driving the car, one of the use cases is pay-as-you-go insurance. So a personal story of mine is there are companies that are doing this pay-per-mile insurance. So there's one called Metromile, where I actually personally switched to this company called Metromile, where my car insurance before was around $120, $130 per month. And a lot of times, I'm at work, or maybe I'm traveling a lot for conferences and things like that. So because of that, the car is just sitting in my apartment. It's not doing much, right? When I switched over to Metromile, my car insurance went down to about $40 a month versus $120 a month, because if I'm out traveling or doing whatever, the car is not running and they're not billing me for it. Another one use case is Progressive introduced this one called Progressive Snapshot, where they analyze your driving patterns and they say, okay, for this much amount of time, you're actually a great driver, so we'll give you a discount on that. And then if you drove recklessly for X amount of time, then they'll say, we'll give you a penalty for that. So over time, you can get this sort of tailored price for how you've driven, and then get a safer driving there, where the insurance companies are doing some really cool work in this connected car space.
That's pretty cool.
Yeah, another use case is, if you're driving the car, then they've really come a long way for the safer telematics. So this is not just, ensuring that the car is not drifting away from the lane, but you can imagine the scenario where you can marry people's profile data from the real-time data that's coming in from the car. So, for example, I speed a lot. So because of that,
you know this about yourself.
I know this about myself. Everyone else knows this about me too. So because of that, I slam on my brakes a lot, because you speed a lot, the car in front of you stops, right? So Toyota also might know this about me, and they over time have analyzed this driving pattern. Yeah. So because of that, they have these thresholds that they've set for brake sensors to say that whenever a brake sensor hits a certain threshold, we should alert this user to take their car into the shop. But they can marry that with the profile data to say that, Raghav speeds a lot because of that he slams on his brakes more. We should alert him faster than the average user, because he might need to take his car into the shop for the brakes to be replaced faster, right? So you can have this sort of personalized recommendations in the safer driving scenarios for there.
That almost seems like fleet management, where the fleet is just the general public as opposed to a fleet of rental cars.
Yeah, exactly. And so this is really bringing the power of that scenario to the mainstream, and Kafka can handle millions of events per second, and that's where the power of Kafka really comes in to bring that scenario to life. Another, very futuristic scenario here is the automated cars. And as we're moving more into these automated car scenarios, connected car platforms and the data ingestion is just the bread and butter, right? Like, you're going to need to get all the data from the car in real time, and then you can even power up scenarios like, maybe Cortana in the car and the productivity suites within the car once you have these things coming for the automated car scenarios, so that you can get your work done, because now you're not actually driving the car. So, so these are some of the scenarios that we are very excited to work with Toyota to power up, and HDInsight Kafka has been at the forefront of these technologies to power this scenario.
That's cool. It's nice to imagine someday would I be able to actually touch a car and experience this this future that you're describing?
Yeah, so actually today, if you have the new Prius or the new Camrys, even the new Siennas now, you can have this.
Really?
The new Priuses and Camrys are getting their data flown in through Azure Kafka. So
the future is now.
The future is now. You can go to a dealership and just get the car today and drive it, and then get the data flowing in and have that safe knowledge for the data flowing into Kafka.
That's fantastic.
Yeah.
So they're building this on top of Kafka.
Yep.
And they're using what kind of technologies?
Yeah, so they're using, I'll go through an architecture of what this looks like at a very, very high level. So you've got all the cars that are deployed out in multiple different regions. You know, Toyota is a large company in multiple countries, and they've got millions of cars out in every single, you can think of city. And they're sending, they have these cars out there, and they're sending data of each minute with these 4G and 5G network cards that are placed within the car. And these are, some pretty heavy duty networks that are sending data packets from within the car. Mm-hmm. And they send the data to Azure Gateway Services that act as load balancers, and they're going to send data to multiple Kafka and Spark and Storm instances that are deployed within the Azure cloud. They do this for multiple reasons, like disaster recovery and also for scalability purposes. Mm-hmm. And from the Kafka, they're going to process this, they're going to ingest the events, and then they're going to process it with Storm and Spark. And then they're going to either pipe the events out for long-term storage for other vendors to purchase the data, or other real-time applications like the alerting that we had just talked about, or even real-time dashboards for other companies or even themselves to analyze which cars are actually having brake sensors that are failing more, which cars are in the green zone and things like that. But instead of me talking about this connected car architecture, why don't I actually show you a connected car here, and actually we're going to have you drive the car here. So I've actually built out a prototype of this connected car architecture in this little toy car. My boss didn't give me enough money to get a real car out here, but just to wrap our heads around what we're going to look at, instead of actually having a real car, this is a toy car, but it has an accelerometer built onto here. Yeah. So that's going to mimic the sensors that are within the car, like the brake sensors and the other data sensors that are sending the data. Right. And then I have a Bluetooth module that is programmed on this Arduino. Mm-hmm. So that is going to act as the 4G, 5G network cards that are going to send the data to, and this is going to send the data to my laptop, which is going to act as a gateway. It is going to send that data to the Kafka in the cloud, and then we're going to see a dashboard that I've programmed that is going to show the data being consumed from Kafka. So you can see as you will drive this car up and down, the data come through. So let me turn the car on.
And it's a Toyota, even better.
It is. It's a Toyota. All right. So I'm going to give you this. All right. And if you go on the left one, if you go straight, sorry, I'm going to switch to this.
Do you want to show the big screen? So, that's what do you want to switch?
Yeah, exactly.
So we've got another laptop here. Let's go ahead and switch him onto that other laptop. And here we go. So this is all real here. You've got your connected car dashboard on the left.
Yep.
You've got your Kafka node looking at all the messages being sent.
Yeah.
And then you've got kind of a dashboard here.
So this is how you would actually program this. So the COM5 is the port that is sending the data to the laptop, but that's the Bluetooth port. So you can see as you go up and down, that dial moves. And that's it's important to know that that dial is moving because it's coming from data in the cloud, which is the Kafka.
Oh, wow. Okay, so let's see if I understand this. I go in, this moves, the accelerometer sends it over Bluetooth, where Bluetooth is our personal area network, all the way to the machine, all the way up to Kafka, gets ingested into Kafka, sitting on HDInsight.
Which is right here.
Which is right here. And we can see that it's connected. This is real. And then the connected car dashboard. So look at that. That's pretty fast, too. There's not a lot of delay there.
There's not, and in fact...
This is real streaming data.
It is real streaming data. In fact, I had to program a delay because, my laptop would have died. Kafka can handle millions, even billions of events per second, but my laptop would have died just processing the load from this, so I had to program that delay here.
You had to program a delay because it was so fast.
It was so fast, yeah.
Okay, so I understand that Kafka is used for ingestion. What is it about HDInsight that makes Kafka better?
Yeah, so if you switch back to the laptop here.
Okay.
So, we added Kafka, as we discussed last year, on HDInsight family, and we added that because if you look at how people really deploy these open source streaming pipelines, then there's a big gap missing for the event ingestion space here. And, for the open source streaming pipelines that, Toyota or all these big companies want to deploy out, they really wanted to use Kafka, so we looked at the Kafka as adding a workload there. And they were really concerned with the manageability aspects of Kafka, with the security, the monitoring, and the deployment, because that seemed to be a pain point for them on their own architectures. So we went ahead and added that to the HDInsight family. So not only do we have a managed Kafka service, where through 4 clicks on the portal, you can get a Kafka cluster deployed out with a 99.9% SLA for the broker uptime. We also give you the tools to take advantages of all the features of Kafka within the Azure environment. So for example, rack awareness is a feature that is built into Kafka, but it was built in with a single dimensional view of a rack. And that works for cloud environments other than Azure. But on Azure, the rack is more of a 2-dimensional view, where you have the update domains, which are the horizontally where Azure pushes out the updates. But then you also have the fault domains, which are the actual machines that are attached to a single pod. So we do a lot of work to translate that to a notion of a rack within Kafka, and then we give the tools to the customers to actually take advantage of this, and we monitor that on our own services so that we can give that really, really high level of SLA for the Kafka uptime.
And it's still Kafka. You didn't have to change anything, and your application doesn't have to think about it.
Yep, it's still Kafka. We have not changed anything in the open source Kafka. We work with Hortonworks to get the Kafka bits, and we've also been working with LinkedIn as well, because Kafka was born at LinkedIn, and so that's it's still Kafka, all open source. But when we look at these, the problems that enterprises have had for deploying out Kafka, one of the big one was cost. Because Kafka is an I/O-heavy technology, so because of that, they were adding really, really beefy nodes to Kafka clusters. So we looked at Azure Managed Disks, which is a feature that was released last year. So before the native integration with Managed Disks, you were limited by how much storage each node could have. So once we integrate with Managed Disks, now we can attach up to 16 Managed Disks per Kafka node. Wow. So this means that your storage goes up by 16 terabytes. But the key factor to notice here is that the cost of a disk is actually the fraction of the cost of a node. So because of this, now your costs, even for something like Toyota scale or being at scale, goes down by an exponential amount of time. And your scale actually increases because now you can have less nodes, but you can handle more events, and you can have smaller clusters for even a higher workload there.
Thus making it possible to manage thousands or millions
Correct.
of cars.
Yep, that is, yeah. And we've integrated really well with Operations Management Suite and Azure Monitoring. So, instead of me actually showing you the slide here, why don't I actually show you the quick demo of Operations Management Suite here.
Sure, briefly.
And how this integrates. So, if we just go Google HDInsight Kafka, then we can see that we've added a learning path at the end here. So a lot of times customers ask, how can they deploy out Storm with Kafka, or how can they deploy out Spark with Kafka? So if they just click on this learning path, they can learn about the Kafka. But then if they go to the Kafka with Spark, then you can see how we've got the templates that we've already created, and we have a nice documentation article here. But if you click on this deploy to Azure, then this will take you to a link where we've already pre-populated an Azure template, and this will do everything from the VNets to the Kafka clusters to the managed disks. You just have to put in the parameters here. Once you do, this is actually pretty powerful, because getting something up and running for this scale for enterprises has been actually a challenge for a long time. So once they do actually deploy that out, you can see that you will have all the resources that are pre-populated. You have the Kafka cluster, the Spark cluster, and the VNet, and a storage account, all within 10 to 15 minutes with just 4 clicks that you could get.
Something that would have taken you a weekend or more.
For large companies, this is actually an enterprise scale streaming pipeline. So for some companies, it would take you months to even get up and running, install the bits, configure all the virtual networks, configure the gateway rules, do all the disks attachments.
Right. But now that best practice is encapsulated within that Azure resource template.
Yes, and we've optimized these clusters for the highest availability. We've given the highest security possible, and things like that. So just to show a quick example of this, I have created a Jupyter notebook that is going to send data to Kafka, And from there, we're going to read, and these are all prepackaged notebooks, so you can just get them for free when you deploy the cluster.
Sure.
They've got real-life examples of streaming from Kafka, and then also writing these events out to storage and viewing them out. So once you run through these examples, I'm not going to go through what this example, or go through the full example, but this example is just streaming in data for simulating a taxi cab simulation scenario, where it's going to just simulate all the pickups within a certain area for a taxi cab within the New York City area. And if we look at the Kafka, you can see how the events are actually streaming in real time into the Kafka.
That's all live of a simulated taxi fleet?
It's all simulated taxi fleet, and the events are coming into the Kafka topic. And you can process these. I'm piping them out to a real-time SQL table within Spark, and then you can not only process these, this is still running, but once you process these, then you can...
There. Look at that.
Yeah, so that's the Yarn application ID. It will go through, but while that's going through, I'll show you quickly the monitoring aspect of this cluster. So if we go to the cluster dashboard, then you can see that on the left-hand side here, there is a monitoring tab here. If I click on that, then that is where we've integrated very well with Operations Management Suite. You can either enable or disable it. It's highlighted disable because we've already enabled it for it. But if you actually go to the dashboard, let me refresh this. This is going to show you the incoming bytes that are going into the Kafka cluster and out. And we should see, exactly, we see a spike there because we had just sent all those data to the Kafka cluster, and Kafka started to process all those events. And not only can you, alert on, not only can you monitor these, but you can also alert on these metrics. And this is really powerful because once you can alert on this, then you can say that, once my Kafka disks are 80% full, add another Kafka node to the cluster. So this is why, we have integrated very well with Operations Management Suite to give our customers that level of manageability, that level of monitoring, that level of scalability with Kafka.
So there's a ton of information here. You've got great documentation. You've got learning paths. Go out and pick your favorite search engine and find the Apache Kafka section of Azure. You can learn all about Kafka on HDInsight. Check out the learning paths. You've got multiple learning paths and fantastic documentation. And even though this seems like a huge amount of information, there's a depth of knowledge going on here and that people can dig into.
Yes, and all of these examples make it really easy to get up and running and pipe data from either any real-time stream that you want to all the way out to either storage accounts or Power BI dashboards.
Fantastic.
Yeah.
I am learning all about Apache Kafka on Azure HDInsight here on Azure Friday.